Every day, in these specialized facilities, more than 3,500 aloe vera leaves are processed, a figure that reflects the scale of an industry that, although quiet, supports thousands of families and supplies markets around the world. To put it in perspective, producing just 4 liters of pure gel requires around 20 mature leaves. And even then, that is only the first stage of a much more complex process. This leads to the big question: how is it that those thick, serrated, rugged-looking leaves end up transformed into the crystalline gel we find in creams, juices, masks, soaps, and dozens of cosmetic and medicinal products? To answer this, we ventured into one of the most impressive aloe plantations on the planet. Mexico, thanks to its privileged climate and the agricultural traditions of several regions, has positioned itself as one of the world's giants in aloe vera production, with about 11,000 hectares dedicated exclusively to this crop. Most of these vast plantations thrive in arid and semi-arid lands, where intense sunlight and scarce rainfall favor the growth of this resilient succulent. And it is in the state of Puebla that one of the largest plantations in the world can be found, an endless expanse of greenish-gray, where every plant seems placed with almost millimetric precision. Producers organize their fields in raised rows, an agricultural technique that not only facilitates water drainage, but also allows for better air circulation among the plants. This prevents the appearance of fungi and pests, and also makes the harvester's work much more efficient. Although aloe is famous for thriving with little water, irrigation remains a key factor in obtaining juicy, high-quality leaves. For this reason, farmers build channels and gravity-fed irrigation systems that transport water from nearby rivers, ensuring stable moisture even during the driest months. The yield of the entire operation depends on this supply. Aloe leaves are true natural hydration reservoirs. They are composed of 95% water, but they also contain a powerful cocktail of minerals, B and C vitamins, enzymes, amino acids, and antioxidants. This combination is responsible for their widespread use in skincare treatments, anti-inflammatory products, cleansing beverages, and traditional remedies. Like any good succulent, aloe stores water in its fleshy leaves, which allows it to survive for weeks or even months without rain. However, its growth is slow. It can take up to 3 years to reach the optimal size for its first harvest, a process that requires patience and constant care. At 8 a.m., when the light is still soft and the temperature begins to rise, activity in the fields begins. The manual harvest starts, a task that requires experience and precision. At this stage of maturity, the inner gel has already reached its characteristic thick consistency and contains more than 200 bioactive compounds, among them polysaccharides that promote deep hydration and glycoproteins capable of stimulating skin regeneration. Workers select only the outer leaves, those that have reached between 40 and 60 centimeters in length and a minimum weight of half a kilogram. The inner, younger leaves are left intact to ensure continuous plant growth. Thanks to this sustainable practice, each plant can produce for a full decade. In total, about 750 people participate daily in the selection and cutting of the leaves. Everything is done early to prevent midday heat from reducing the amount of available gel. By the end of the day, around 7.5 tons of freshly cut leaves have been harvested, ready for the next step. Once cut, the leaves are carefully loaded onto trucks. 2 or 3 months will pass before workers return to harvest the new leaves that have grown. Aloe gel is extremely delicate. If it is not processed quickly, it begins to oxidize and loses some of its properties. For this reason, the trucks travel about 25 kilometers to the factory, where an extraction process must begin with almost surgical precision. These plantations not only supply the national market, they are an essential link in the international trade of aloe vera. Export companies install their processing plants very close to the fields to ensure that the leaves arrive fresh. There, the cleaning, extraction, filtration, and stabilization of the gel take place, after which it is packed into large containers and shipped to manufacturers of cosmetic and pharmaceutical products in Asia, Europe, and the United States. Each day, approximately 118 tons of freshly cut leaves arrive at these factories. After completing the full process, they are transformed into roughly 75,000 liters of pure gel, ready for global distribution. The first step is cleaning and disinfection. The leaves are submerged in a gigantic tank containing 10,000 liters of chlorinated water, which removes insects, soil, and microorganisms adhered to the leaf surface. They are then rinsed with running water to remove any trace of chlorine. Only then can they proceed to the next stages, where the rind is separated, the gel is extracted, filtered, and finally stabilized to preserve its properties for a longer time. Extracting the gel that rests inside aloe vera leaves is a process far more complex than it might seem at first glance. It is not just a matter of opening a plant and scraping out its interior. The natural viscosity of aloe, dense, slippery, and slightly fibrous, turns every movement into a challenge that requires skill and absolute control. The process begins by removing, with perfectly sharpened blades, the serrated edges that protect the leaf. These hardened filaments, although they may seem harmless, can easily tear the skin, so the cut must be made firmly and precisely. Once the edges are removed, a team of highly experienced workers steps in, their skill bordering on surgical. Each one holds the leaf with one hand, while with the other, they slide the blade along the plant's natural curve. They carefully open the leaf along the sides, separating the green rind from the translucent pulp. What they extract is a gelatinous sheet, almost like a trembling, shiny fillet, representing the very essence of aloe. This fillet, pulsing with a watery texture, will later become the base for creams, body gels, hydrating serums, facial toners, and countless cosmetic products. And speed matters. To meet demand, the team must fillet around 3,500 leaves every day, maintaining a steady rhythm for hours. Although in many regions of the world this process has already been mechanized, here the traditional method is still preserved. Everything is done by hand, with simple tools and the skill that only comes from years of practice. This decision is not only cultural, but also practical. Manual work allows for more precise visual and tactile control, reducing the chances of mixing bits of rind or aloe in with the pulp. The plant residues, peels, fibers, and dry fragments are not wasted. They are returned to the field and transformed into a nutrient-rich fertilizer, closing a natural cycle that feeds the same soil from which the plant emerged. The collected fillets are placed in large containers that first pass through a scale. This allows for accurate monitoring of each batch's yield. Then, the contents are poured onto an inspection table, where workers examine each piece one by one. They meticulously search for any tiny fragment of rind or fiber that may have adhered to the gel. If they find any impurity, they remove it immediately, because even a single particle can affect the quality of the final product. Once the visual inspection is complete, it is time to remove the aloin, that yellowish, bitter liquid that runs beneath the leaf skin. Aloin is a natural compound, but one that can cause irritation and act as a powerful laxative if ingested. Its removal is mandatory and is carried out through meticulous washing with clean water and draining techniques that leave the gel completely free of this component. Once purified, The fillet passes through a special mill that grinds the pulp until it becomes a homogeneous gel with a smooth, uniform texture. This gel is filtered several times through meshes of different thicknesses to ensure that no unwanted residue remains. At this point, ascorbic acid, vitamin C, is added, acting as a natural antioxidant that prolongs the product's shelf life, preventing it from degrading or changing color. However, the fresh gel presents a logistical challenge. It is extremely delicate and difficult to handle. To make it more stable, it is cooled to 5 degrees centigrade. At this temperature, the gel acquires a firmer, more manageable consistency, allowing it to be packaged more easily into 200-liter barrels. From the moment the leaf is cut in the field until the barrel is sealed, approximately 3 hours pass, a race against time to preserve the gel's freshness. But the aloe's journey does not end here. Each barrel must pass a series of strict sanitary controls before receiving final approval. Specialized technicians take samples of the contents and take them to the laboratory, where they are analyzed for an hour. They look for bacteria, molds, yeasts, or any sign of contamination. If a single parameter fails to meet the standard, the entire batch is discarded without exception. Only the barrels that pass all tests continue on to the industries that require them. The approved batches are distributed to manufacturers in different parts of the world. In these factories, the gel becomes an essential ingredient for cosmetic, pharmaceutical, and nutritional supplement products. Among the regular buyers is a well-known British beauty company. There, the aloe is mixed with oils, synthetic waxes, and emulsifying agents in enormous automated tanks. A computerized system regulates the speed of the mixing blades, controls internal pressure, and maintains constant temperatures to ensure that each batch meets the exact required quality. For the oils and waxes to integrate properly, the initial mixture must be heated to 75 degrees Celsius. However, the aloe cannot join the mixture yet. At that temperature, it would lose its soothing, moisturizing, and regenerating properties. Therefore, the gel is incorporated only when the mixture has dropped below 40 degrees Celsius, a critical moment in which its bioactive compounds remain intact. A single 200-liter barrel can be transformed into up to 16,000 hand cream tubes. To ensure that the formula maintains its balance, the volume of aloe added must be accurate down to the last milliliter, no more, no less. To avoid waste, a special machine squeezes the barrel almost completely, ensuring that as much gel as possible reaches the mixing tank. After about 8 hours of continuous agitation, the cream is ready to be packaged. An automated line then springs into action, and it must work quickly. If the mixture cools too much, it hardens before reaching the tubes. In the filling room, the cream, still warm and fluid, becomes 4 tons of product distributed into 16,000 containers in just 4 hours, which equals more than 1 tube per second. Each one of these containers passes through an optical sensor that verifies its exact position before filling. Interestingly, the tubes are not filled from the top, as many might assume, but from the base. This speeds up the process and reduces the risk of air bubbles. To seal them, the base of the tube is heated to 320 degrees Celsius, hot enough to soften the plastic without melting it completely. Then several samples undergo pressure tests of up to 4 bars for 10 seconds, ensuring the seal is solid and resistant. Only then, once all controls have been passed, are the tubes packaged and sent to distributors and cosmetic stores in different parts of the world. And so, a product that millions of people apply daily to their hands or skin has an origin that stretches far further back. A humble aloe leaf, carefully cultivated, filleted, processed, and transformed over the course of a surprisingly complex journey.